Hello, everybody, and welcome to another episode of Echo Live. Actually, it is a great episode if you are tuning in for the first time or maybe even the 100th time, because today is going to be a very big, very exciting day here at the Michigan Science Center. We are celebrating our 100th episode. You might know that we launched Echo Live all the way back in March, less than a week after schools closed to the public here in Michigan. Since then, we've provided 99 episodes of exciting science content right here on Facebook, YouTube, and in Zoom. Like I say on every episode of Echo Live, if you haven't done so already, feel free to go ahead and introduce yourself in the chat of whatever program you are tuning in on. I'd love to see some familiar faces and maybe some new people tuning in on Facebook. So tell us who you are, where you're watching from, and maybe what you think we're going to talk about here on this episode of Echo Live. You might be able to tell based on some of the materials that I have here on my table, but I've got some surprises in store for us all. Now, I'm pretty excited about today's episode because you might be able to tell that I'm not in my distance learning studio. In honor of our 100th episode, I decided to pick up my stuff, move out here to the Chrysler Science Stage right here in the very center of our facility here in Midtown Detroit, and to show off some of the biggest demos I know how to do. And I mean literally big. Things that are too big, maybe too messy or too dangerous to try in my basement where we were broadcasting from for a few months way back in March. And maybe things that are just a little bit too big to fit inside my very tiny but very effective distance learning studio. So we've got a great day planned. We are going to talk about some of my favorite experiments, and we're going to relate all of these, of course, to a little bit of science called Newton's laws. Now, we've talked about Newton's laws a bunch here on Echo Live, so let's do a quick review before we get started with some of our demonstrations. Hi to everyone who's starting to introduce themselves in the chat. I saw Owen tuning in on Facebook. Hello to everybody out there watching. Now, our quick recap of Newton's laws. We are familiar with law number 1 that says a body at rest will remain at rest and a body in motion will remain in motion unless it is acted on by an external or outside force. Pretty simple stuff there. It does a great job of explaining what we mean. If you're at rest, you'll stay at rest. If you're in motion, you'll stay in motion unless some sort of outside force, whether it is visible or invisible, changes that. Law number 2, we don't talk about quite as often, but we are going to discuss how the force on an object is equal to the mass, the amount of stuff inside that object times its acceleration. You might know this in math terms as capital F equals little ma. F means force equals mass times acceleration or change in speed. Now, law number 3, one of our favorites, we've talked about this one quite a bit, that for every action, there is an equal and opposite reaction. So let's go ahead and let's put these laws to the test. But I said we're going to be doing some big things here today. And before we do any sort of dangerous activities, normally we talk about safety first. But in fact, these demonstrations are a little bit too big, or at least most of them are a little bit too big for me to do on my own. So instead of talking about lab safety, where we normally talk about things like wearing gloves or a face mask or hearing protection, things like that, instead we're going to talk a little bit about COVID safety. Since I'll have an assistant joining me here today, Andy is going to be joining us. And so COVID safety means that since we won't be able to maintain social distance for some of these activities, we're both geared up with our safety equipment, face masks ready. If you are going to be doing any sort of activities with people who are not in your immediate bubble, don't live in your household, safety first always, put on your mask. They're super cool, super fashionable, and we endorse them here at my side. All right, Andy, so we're going to get started with our Newton's laws demonstration. Will you hop up on this platform for me?
Absolutely.
All right, now, Andy is going to step up here on a rotating platform. We've seen this one just before. Now, get your balance there. How do you feel?
Kind of spinny.
Kind of spinny. So let's go ahead and we're going to spin you around, but I'm going to bring you to a stop. And the object is right that unless Andy gives any sort of force, right, unless he moves, theoretically, he should stay at rest until he is acted on by an outside force. Now, how could we possibly give Andy an outside force? What could we do to disrupt the system? Tell me in the chat, but Andy, what could we do?
I could do this a whole bunch.
Ooh.
And hopefully keep moving.
You could have a dance party. That's true.
That's true.
What What if I was the outside force? What do you think?
What do you have in mind?
I think I might give you a little bit of a spin. Do you feel okay with that?
Yeah, sure.
All right, here we go. So we're going to give Andy an outside force. And now Andy is in motion. And until an outside force comes back in, Andy, what are you going to do?
Keep moving.
Keep moving or stay in motion, right? Now, we won't do that to Andy for too long. We'll go ahead and we'll gently bring you to a stop. Now, the reason this works so well is because the platform that Andy is standing on has very, very low friction. Not a lot of friction slowing him down or stopping him from spinning. So until we stopped him, Andy would keep spinning until he either jumped off or until another kind soul were to come over here and bring him to a stop. Now let's try something else, Andy. Now, do you consider yourself, have you been working out during quarantine?
A little bit. Yeah.
A little bit, okay, great. So we've got some pretty heavy weights here. I'm just kidding, they're about 5 pounds each.
Okay.
But we're gonna demonstrate Newton's second law, meaning that force equals mass times acceleration. Since we've added mass or the weights here to the system, Andy's force is going to be much greater this time around when we give him another spin. So here we go. All right, now Andy probably doesn't feel any different, but I can feel the difference. It took a lot more of a force for me to get Andy spinning this time around, and it should take me a little bit more of a force for me to bring him to a stop. Did you feel that?
A little bit, yeah.
Yeah, a little bit. Now, our very last one is going to test Andy's balance, but we're going to demonstrate Newton's third law, that for every action, there is an equal and opposite reaction. And I'm not sure, have you ever figure skated before?
No, I haven't.
Never figure skated. Well, we're going to find out if you might be good at it. The Olympics are coming up. I know they're canceled this year, but fingers crossed for the next ones. Winter Olympics are pretty exciting. Now, have you ever seen one of those figure skaters who starts to spin and they bring their arms in super tight to their body?
Yeah, absolutely.
We're going to give that a try. So what we're going to do is give Andy his push or his outside force.
Okay.
Now go ahead, Andy, and slowly bring those weights in towards your body.
Okay.
And look at that. Andy, what do you notice?
I'm moving much faster.
All right, now put your arms slowly back out. As Andy brings his arms out, he slows back down. When you bring your arms back in, show us one more time. A little bit faster there and back out. Slows back down. All right, awesome, Andy. You can step on down. Hopefully your arms aren't too tired there. But let's talk a little bit about the science, right? When Andy brought his arms in towards his body, we say that his moment of inertia decreased. Since we had a decrease in one variable or factor, his velocity or his speed went up. So a decrease in inertia or distance resulted in an increase in speed, which is why he started to spin much, much faster as his arms got closer to his body. When he brought his arms back out, we had the opposite change, right? Equal and opposite. Arms go back out, moment of inertia increases or goes up, so your speed goes down. All right, now, I know we've been working on something together that's a little bit big. Now, we've seen this before, but we've got this kind of funky looking contraption. Andy, what are we calling this?
So this is something new we're working on called the Tiltorama, and it's still kind of in the testing phase here. Like Anna said, some things might be a little more dangerous or obviously too big for us to try in the studio. So you want to give it a try?
Yeah, okay, I'm gonna move this way. If you could grab the ladder,
Okay.
that'd be great, okay. All right, I'm pretty excited for this. Like we said, it's a little bit bigger, maybe something a little more exciting. This contraption behind me is not going to fit inside my distance learning studio. You might notice that there are some weights down at the bottom, and so I can definitely see how maybe the second law could come into play here. All right, Andy, after you.
No, I demonstrated the last one. You can give this one a try.
No, I think that everyone at home really wants to see you do it again. You did a great job, you know?
No, I think it's your turn, Anna. You can give it a shot.
How about we rock, paper, scissors for it then?
That's fair. All right.
All right, so on shoot, of
All
course, ready? Rock, paper, scissors, shoot. All right, it looks like I'm going up on the Tiltorama, so I guess 100 episodes is enough. If I don't see you next time, it's all Andy's fault. But okay, all right, fine. So just go on up.
Yep, going up the stairs. Anna, we've been using this a little bit. I'm sure. I think it'll be fine, but let's just see what happens.
Ooh, okay.
All right, so
Woo, it's high up here.
step all the way back, and we're going to close the gate here in front of you and lock you in. And just to make sure it's super duper safe, I'm going to get the stairs out of the way, and
Okay.
we're going to make sure your ankles are held in place as well. So there's a little
Okay.
dial I have to turn on the back of this thing. So bear with us here.
Oh boy. Oh boy. All right. I don't know about this, Andy. You didn't say anything about being like locked to it.
Well, yeah, you're good. I mean, your feet are probably 7 feet in the air. So, I mean, how do you feel up there right now?
Pretty good, actually. It's not really moving or anything, so I feel all right.
Well, here's the surprise. I'm going to unhook these chains at the bottom of here, and
Okay.
it's really going to be up to you. We were talking about balance earlier on the turntable. It's going to be up to you to balance, Anna. So
Oh, boy.
I hope you're prepared for this. So here we go. There goes one.
Oh boy. Oh boy. Okay. I can feel it starting to move. I'm trying my best.
Yeah, okay, you got one more left here, so you're going to be on your own. Ready?
Okay, I'm ready.
And number 3.
Oh, okay. Oh my goodness. Ah!
Here we go.
No. Okay, I feel
doing pretty
you know,
well up there.
yes, I
but,
feel actually I'm doing a really good job. We're good. Woo.
All right. Do you think you have pretty good balance, Anna?
I do. I think so.
You sure?
I mean, I snowboard, so yeah.
Should we find out though? So I'll tell you what I'm going to do, Anna. It looks like this thing can move pretty easy. I'm going to give you a little spin like you did to me on the turntable.
Oh man, I don't know that that's the same thing, Andy. Oh my gosh.
And there we go. Now, you're starting to tilt as well. It's really up to you, Anna, to keep this thing balanced. I hope you don't fall over here, but.
Oh man. Look at that though.
Starting to balance yourself.
Yeah, I feel like I'm not really doing it. It's almost like it's doing it itself.
All right, so I'm having a little bit of fun with Anna here. What we're doing, we're talking about balance earlier, and a balance point on an object is the average position of mass of the object. So right now, although it looks really scary because Anna's way up there and she's weebling and wobbling all over the place, the majority of the mass in here is down at the bottom. As much as it seems like she's about to fall over, she won't. So there's probably about 500 or 600 pounds at the bottom. Even though Anna's up at the top, the average amount of weight is at the bottom. So although it's really fun and kind of scary, she's totally safe up there in the Tilt-O-Rama.
Oh boy. All right. Okay, so no matter what I do, I can't fall off, right?
That's correct.
Oh, but how do I get out?
How do you get out? You can jump if you want. No, we'll bring you back down. We'll put the safety chains back on.
Oh boy.
I'll bring the staircase back around.
Oh,
How was that, Anna? Pretty fun?
That was pretty fun, actually. And this is a really great way, like we said, to demonstrate more of Newton's laws, because once I got spinning, I really couldn't do anything to stop it. Couldn't reach anything. And like the weight, definitely I could feel pushing me out away, even though I wasn't doing a whole lot. So this is pretty awesome. Now, can people try this if they visit my site?
Pretty soon we are looking to start a new show on our science stage, talking more about our Newton's laws and bringing in some even cooler demonstrations. So we're hoping very soon to bring this back to the science stage and do some really cool demonstrations.
Well, thanks. That was super cool. And you guys should all come check it out. That was only a little bit terrifying, but still pretty fun. All right, now we've got a couple other really amazing, awesome things planned. You might notice that I brought out some liquid nitrogen because this is truly one of our favorite experiments to do here on Echo Live. We love to do a couple things with liquid nitrogen. We've done all sorts of cloud making, freezing stuff, crushing stuff, experiments like that in the past, but we said we're talking about Newton's laws today. And the best way that I truly know how to demonstrate Newton's third law, that for every action there's an equal and opposite reaction, the best way I know how to do that is to launch a rocket. We've done some small scale stuff, but we said we're going big today. So we are actually going to power a rocket using some liquid nitrogen, and we are going to exert a force down towards the ground, which is going to propel our rocket, AKA this empty bottle here, towards the ceiling of the Science Center. Now, this is going to be quite large, but of course, when we're working with liquid nitrogen, which I've already done a little bit of work before the show and poured down here into my thermos, which is just a small version of our Doer, we have to be safe. And so I am gonna put on my cryogenic gloves. These gloves are here to protect my skin because that liquid nitrogen, like we know, is negative 321 degrees Fahrenheit, super duper cold stuff. And then of course, on my head here, it's not quite good for safety if it's this loose, but we have a blast shield. And this is of course here because since we are launching a rocket, we do need to deal with some sort of explosion. And so I definitely want to be extra safe. So we've got our blast shield here for when it's time to let that rocket go off. Now, the way this is going to work is we're going to pour just a tiny, tiny bit of liquid nitrogen down here inside our empty bottle. When we do that, the liquid nitrogen is going to immediately start evaporating or boiling because liquid nitrogen has to be negative 321 degrees Fahrenheit in order to exist as a liquid, which we are about to see. If it gets any warmer than that, it immediately starts to turn back into a gas. That gas makes up about 80% of the air that we breathe. It's around us all the time. So nitrogen in its gaseous form, really nothing to be afraid of, but in its liquid form, it's a little bit more dangerous. Now, before we launch the rocket, we can see some of that evaporation starting to take place down in the bottle. You might be able to see some condensation forming as it rapidly cools the water vapor in the air around us. But this stuff really is boiling. When it does that, it actually starts to take up much more space. It is expanding. We say that the expansion ratio of liquid nitrogen is about 700 to 1, meaning it takes up 700 more times as a gas than it does as a liquid. Our goal in this experiment is going to be to take our bottle, plug it with this little rubber stopper here, let the pressure build as that gas expands and expands and expands until the pressure becomes too much for the bottle to handle, launching it towards the ceiling. Now, we'll definitely want this outward view here. So let me go ahead, adjust our view just a little bit. And if we're lucky, I might catch the bottle. We might be able to try this one more than once. But I'm gonna go ahead, drop down our blast shield here, pour just a little bit more liquid nitrogen in the bottle because I think we've had most of ours evaporate away at this point. Doesn't take much. We'll go ahead, get our experiment set up. We'll take our rubber stopper here, really plug this bottle. Here we go. In 3, 2, 1. Actually landed right behind me. Now, hopefully it looked pretty cool on camera, but what I think might be even more fun is if I turn the camera up just a little higher, instead of watching the launch pad this time, I'd like to see if we can get a view of what the rocket looks like as it launches towards the ceiling. And if you hear kind of a loud thud after the rocket goes off, that's actually this rocket hitting the ceiling. It actually just did that. You might have heard it, but hopefully we'll get to see it on camera this time. All right, so we're starting that over. I will talk you through my steps here. Enjoy the nice view of our very, very beautiful purple ceiling up there. Let me know if you see any birds flying around that might need to take cover. All right, I'm pouring in our liquid nitrogen, setting up our experiment one more time here. I am plugging the bottle with our rubber stopper. Plugging again with our rubber stopper. We are flipping, letting the pressure build and launching in 3, 2, 1. I think it went off even too fast to catch down there on the screen, but we did have success. If you couldn't see it, hopefully you could hear it, but this is our great demonstration of Newton's third law, right? That action, that force pushing down on the ground as that liquid nitrogen tries to exit the bottle is enough to push that bottle up towards the ceiling, getting it to strike that way, way, way high up there. I'm not even sure how many feet tall this is, but it is a very, very tall building. Come check it out in person if you've never been here. All right. Now, of course, we can't end the show without something really, really big. This is a demonstration that I've wanted to do for a really long time, but this one is just that type of demonstration that number 1 is very messy, number 2 is very dangerous, number 3 is very loud, and number 4, I can't do it by myself. And so Andy's gonna pop back over and help us with this one. I'm gonna drop my shield back down. We are going to do an experiment that we like to call the ball plosion. Now, scoot a couple things out of my way here. What we did before, right, is we were able to let that gas exit out the bottle in a safe way because we just had a rubber stopper. But this time around, we're going to put that liquid nitrogen down inside a 2-liter bottle, and we are going to seal the plastic lid. This is going to give the liquid nitrogen nowhere to go. The expansion ratio is the same. So this is a 2-man effort because someone will need to man the bottle, and someone is going to have to do the fun part, which is adding in our ball pit balls over there, Andy. So we're going to go ahead. Down here inside this bucket, we have just a little bit of water, not hot water, just about room temperature water. And all that's going to do is it's going to cause the liquid nitrogen to expand much more quickly. Oh, Andy's got our ball footballs over there. And the only reason we add those is for a little bit of extra fun, like we love to do here on Echo Live. We are going to do this as a team, and it's going to go pretty quickly. You'll see us both run to take cover because, number one, this is a very dangerous experiment. This is going to basically turn into an exploding bottle. It could throw plastic all over the place, so we won't want to be anywhere near it when it goes off. So thank you so much, Andy, for volunteering to help.
Oh, thanks.
All right, we've got our safety gear on. Got our funnel ready. And take a deep breath. We're going to pour our liquid nitrogen down inside the bottle, seal the lid as tightly as we can, which is going to trap all of that expanding nitrogen gas down inside the bottle. As soon as it hits the water inside the bucket, the expansion is going to happen faster. So Andy's going to immediately toss in the ball pit balls, and then we are going to run for the hills, and you guys are all going to watch at home as we have our most exciting Echo Live experiment to date. So here we go. Get just a little bit in there, just enough to cover the bottom. We don't want to rush. We just want to make sure we're being extra sure we get everything together. All right, Andy, are you ready?
I'm ready.
Here we go. In. That gas is expanding. The pressure is building as the bottle warms. And whoa, look at that. Our plastic bottle has been torn to shreds. It could not possibly contain the amount of force that was coming inside that bottle. Where's my mask? Andy and I need to have a science high five. Woo! Thank you everyone so much for joining us for so many amazing episodes of Echo Live. Thank you so much, Andy. If you have any questions, definitely feel free to let us know in the chat. As always, I'd love to answer a couple of those before we go today. But as we always do, before we head out, big thank you to our sponsors of Echo Live. Thank you to Ford and thank you to Denso. They have sponsored every episode of Echo Live since we started, and they are going to continue sponsoring these episodes through the end of the year. You can catch our show every Wednesday at 2:30 p.m. Eastern. We'll do even more science experiments all the way through the end of the year. If you have suggestions, I know a couple people have sent us suggestions and we've got a lot of cool stuff coming up. Let us know, send us a message, send us a comment, send us an email. We would love to do them. And as always, if you're looking for activities that you can do at home, not things like our ball implosion, of course. If you're looking for activities you can do at home, check out our website, mi-sci.org/at-home-science. All right, let's see. Any questions before we head out? Thanks everyone so much for tuning in. Lots of people thought that was super awesome. Good job, Andy over there. He's over there. All right. Thanks everyone so much. We